Okay, so this lesson is going to talk about absolute value graphs and equations. We're not going to focus so much on the graphs because you guys have a graphing calculator and hopefully know how to use it. We're going to be focusing a little more on the equations today. You guys should know about the absolute value graphs in general. Y equals absolute value of x is going to start at 0, 0 and make a V shape with a slope of 1 over here and a slope of negative 1 over here. And then this equation is going to take that absolute value graph and shift it to the right 3 and up 2. So obviously we could graph that as well. This equation would shift the graph left 1 and down 4. So those shifts you should know from earlier in the year. We're not going to graph them. If you needed to, you could always put them in y equals in your calculator, find the points, and plot them. Now in number 2, you're going to use that concept of shifting an absolute value graph to talk about the range of the function. In number 2, that graph, come on, move up, has been shifted. Yeah, not too far. The graph has been shifted. It was shifted left 8 and down 3. So because the graph was shifted down 3, if we kind of use the graph from above, it would go left 8 but down 3. So the bottom part of the graph, or the bottom of the V, would be here instead of here, which means that the bottom of our range will be negative 3. The top of our range will be infinity. The way that we write that is y is greater than, not negative 8, greater than or equal to negative 3. Okay, so we shifted the whole graph down 3, so that took our range down to negative 3. Now, like I said before, the equations are what I'm a little more concerned about. And I really like number 3a. It'll give you a good idea of why we do what we do with these absolute value equations. If you think about taking the absolute value of something and having it equal 8, well, what could we put right there that would equal 8? We could put an 8, because absolute value of 8 is 8. But we also could put a negative 8 in there, because absolute value of negative 8 is also 8. So when we see these absolute value equations, we're going to make two cases. This x could be 8, or it could be negative 8. But you also need to remember when you're solving these to always check. And when we check, you always want to check back into the original equation. But we know that square root of 8 is 8, square root of negative 8 is also 8, so both of these would in fact check. B is going to be a little bit tougher. In this case, all this stuff here, the x plus 7, could be 3, because absolute value of 3 is 3. But it also could be negative 3, because absolute value of negative 3 would also be 3. So now if we solved each of these, subtract 7, x is negative 4, subtract 7, x is negative 10. Now we got to make sure both of these work. If I substitute negative 4 back into here, negative 4 plus 7 is 3, absolute value of 3 is 3. So that one works. Negative 10 plus 7 is negative 3, absolute value of that is 3, so that one works as well. It definitely is possible that one would check and the other wouldn't, or that both of them don't check, and in that case your answer would be no solution. C is a little trickier because we've got this 2 in the front. I don't want to make my two cases until I get rid of that 2, so I'm going to divide both sides by 2. And then I can make my two cases. X can either be 10 or x can be negative 10. Before I circle them, I want to check, so let me go back to my original. 2 times the absolute value of 10. Well, absolute value is 10 is 10, 2 times 10 is 20. Absolute value of negative 10 is also 10, 2 times 10 is 20. So far we haven't had any of them not check, but again, it is possible that they will not check. And in this last one, we've got a bunch of things to move before we can make our two cases. We've got to move the 11 over. 3 times the absolute value of x minus 4 is equal to 21. And then we can divide by 3. Absolute value of x minus 4 equals 7. And now we can make our two cases. x minus 4 could be 7, or it could be negative 7. When I solve each of those, add 4, I'm going to get 11. Add 4, I'm going to get negative 3. But again, we need to check, save some time, mischecks, mischecks. Hopefully you guys trust and believe me that they do check, but always make sure that they check back into the original equation. Don't check back into here or here, always go back into the original. Okay. So go ahead to the back of that page, and we're going to look at number 4. Seems like this is going to be a really long problem because it's asking which of the following has no solution. So most of the time when I show this question to students, they always say, oh my god, we have to solve all of them and then figure out which one has no solution, which one has 2 answers and neither of them check. But you don't have to actually do that. What we are going to do is get all of these so that the absolute value is by itself. So in this number 1, we would add 3, get 5 times the absolute value of x equals 8 plus 3, which is 11. And then we would divide by 5, so that would give us absolute value of x is equal to 11 divided by 5. We'll come back to that. In this problem here in 2, I'll kind of move to the side to do that. We'd want to subtract 6, which would give us 4 absolute value of x plus 3 equals 2 minus 6, which is negative 4, divide. And we'd get absolute value of x plus 3 equals negative 1. We'll come back to that. If you solve each of the other 2, again, save ourselves a little time. This one, when you isolate the absolute value, would give you this. This one would give you that. Now, one of them is going to have no solution. And the reason it's going to have no solution is because when we check back into the original, both of the answers that we get are not going to check. But the reason that's happening is because of this. So 2 is our answer, because can we ever take the absolute value of something and get negative 1? It's really impossible. If we take the absolute value of 1, we get 1. If we take the absolute value of negative 1, we get 1. We can never take the absolute value of something and get a negative answer. It's not going to be possible. We don't have to actually solve all these problems. We know that this one is not going to work because it's equal to something negative. Okay? Number 5, we're going to breeze past a little bit. You guys could plug this into y1, this into y2. Because we're trying to see where they're equal, we would want to see where those 2 graphs intersect. If you actually graph them, they would intersect at 4, 3. And if we actually solved it graphically, you would see, or algebraically, so let's take this and put it down here algebraically, you'd have your 2 cases, 2x minus 5, and then x minus 1 could be, now this is a little tricky because we have to always make sure we set it equal to the opposite of this. So we need negative 2x, and instead of minus 5, plus 5. Now if I solve both of those algebraically, over here we'd get minus x, add 5, 4 equals x. Over here, add 2x, 3x minus 1 equals 5. Add 1, and divide by 3. Now, something must have happened, because the answer that we get when we do this graphically only has the point 43 as a solution, not 2 different points. So what must have happened is this solution here of x equals 2 must not have checked. Let's see. Absolute value of 2 minus 1 equals 2 times 2 minus 5. Absolute value of 2 minus 1 is absolute value of 1. 2 times 2 is 4. Absolute value of 1 is 1. 4 minus 5 is negative 1, and that is not true. So this was a solution, but it didn't check. This did check, which is why we have that as our x value. And if we substitute that in as our x value, that would be our y value that corresponds to that graphically. So we algebraically checked. We did that already. So let's quickly look at, we'll do 2b together. Actually, we'll do 2a. and then 2b I'll give you the answers to. So, not 2, we're on number 6. So we'll do 6a and 6b I'll give you the answer to. Right here, absolute value is already isolated, so we'd make our two cases. X minus 5 equals 2x plus 5. And our second case, x minus 5 equals negative 2x minus 5. The exact opposite on the other side. Now you need to solve both of them. I'm going to skip some steps here. Subtract the x, subtract the 5. So potential answer of negative 10. Over here, add the 2x, add the 5, divide by 3, and a potential answer of 0. But again, we've got to make sure we check. So if I go back to the original equation, negative 10 minus 5 equals, maybe, 2 times negative 10 plus 5. So this would be absolute value of negative 15, which is 15. This would be negative 20 plus 5, which is negative 15. Well, positive 15 is not equal to negative 15, so this answer of negative 10 gets rejected. Now let's check 0. 0 minus 5 equals 2 times 0 plus 5. Absolute value of negative 5. 2 times 0 is 0. 0 plus 5 is 5. So now absolute value of negative 5, which is 5. Is 5 equal to 5? Yes. So 0 works as a solution. Negative 10 does not. Again, it is possible that neither solution could work, and in that case your answer would be no solution, which you could write this way, or you could write an empty set of brackets, or you can write the words no solution. Okay, any of those three would be fine. Now in B, if you guys want to try that on your own, you get solutions of 14 and negative 4, and both of them check. So you guys can try that one on your own, and like we've done with all the other lessons, if you guys have any questions, we can go over them in class, but at least you now have an idea of how to solve absolute value equations.